Welcome! Water is such an amazing material that plays a critical role in how we live, so it's helpful for us to understand it better. Today, we're going to look at water and learn some cool tricks about how it freezes. Have you ever seen any videos showing cool tricks about freezing water? When we watched some videos, we got so curious about how they work, we decided to find out. Today, we are going to explore the way that water freezes by taking advantage of a process known as supercooling. When we are finished, you will understand what supercooling is and what conditions are required to get water to freeze. To follow along, you'll need a few things: a freezer to cool things down, a bottle of purified or distilled water, smaller is better, a glass half filled with purified water, and some strawberries we can freeze. Once we have our equipment, we are going to learn two key things to help answer our question of how water freezes and how we can watch it happen before our eyes. 1. We need to understand the role of supercooling, which is the process of cooling something down below its freezing temperature without it freezing. And 2. We need to understand what seed crystals are and how important they are to the freezing process. Here's our plan. First, we're going to place our bottle of water in a freezer for around 4 hours. After 4 hours, check on it to make sure it hasn't started freezing. If the water is still liquid, remove the bottle and tap the bottom against a hard surface, like a countertop, and watch as the water freezes right before your eyes. If nothing happens, it means your water needs to be a bit colder, so you can put it back in the freezer for another hour or so and try again. Here's a demonstration of the process for you to compare. As the bottle is tapped, you can see the freezing process start from the top and work its way down the bottle. Isn't that cool? Let's think about how this works. Our water has been purified to remove any contamination and sealed inside a smooth, insulating plastic container. This means the water inside has a difficult time organizing into a solid when the temperature drops and will stay a liquid. When we tap the bottle, we create a disturbance that makes ripples and droplets in the air gap at the top of the bottle. That disturbance is enough to freeze a small droplet of water that then acts as our seed crystal to freeze the remaining water in dramatic fashion. Have you been able to recreate the process? If you're having trouble, let's spend some time to review some critical elements of our process. Most important is that your water needs to be purified, or the dissolved minerals can act as seed crystals and prevent supercooling. Try a different brand of bottled water or even distilled water. Also, take a look at the design of the bottle itself. Is the inside smooth, or are there parts that are uneven? Uneven areas can mean a place where freezing can start, so find a bottle design that's more uniform. Finally, where does your bottle sit in your freezer? Cold air sinks, so freezers can sometimes get areas that are colder and other areas that are warmer. If you stand your bottle up, the temperature won't be uniform, and this can lead to premature freezing. Try laying your bottle down in your freezer. If you're still having trouble, let's move on to our next experiment, which is a bit easier to reproduce. For this experiment, we are going to start with a batch of strawberries that we put in the coldest part of our freezer overnight. The next day, take a glass half filled with purified water and supercool in your freezer for a few hours. You can also try this experiment with refrigerated water, but the freezing effect won't be as dramatic. Take your glass of water and place on a countertop, to which we can take a frozen strawberry and dip into the water. Watch the water freeze and pull the strawberry out to see how much ice is formed. Here's a demonstration of the effect. As the strawberry is lowered into the water, you can see the ice form through the sides of the glass, all around the strawberry. Removing the strawberry shows how much ice you made. Let's think about how this works. You can choose any number of frozen things to dip into water, but the reason we chose a strawberry are the little dimples that are all over it. When the frozen strawberry is dipped into the water, the latent heat in the water transfers to the strawberry, and these dimples act as areas where water can crystallize to start the freezing process. This is why, when we remove the strawberry from the water, the surrounding ice looks so fractured and opaque. It's because it's made up of dozens of separate ice crystals. To summarize, we learned that liquids can be supercooled below their freezing point and remain a liquid, in some cases up to 50 degrees Celsius below, if there's no place for freezing to start. We were able to create seed crystals two ways, by jolting a supercooled water bottle and dipping a frozen strawberry into water to watch water freeze before our eyes. We also learned that supercooling liquids isn't as easy as it looks, and we identified a few ways to adjust our experiments for success, like improving the water quality, bottle shape, and cooling orientation. We hoped you liked today's video. Please like and subscribe to get more content just like this.